we are going to continue with verifying identities. So last week we kind of introduced it, saw a couple of ed puzzles on the live lesson last Wednesday. We continued to do more of that. So we're just going to continue that again this week, and then we'll kind of quiz at the end. So we're just talking about the same thing. So as we learned last week, we're going to try to take that more complicated side and we're going to simplify it until we get to the other side. So just another reminder, you can't take this and you're not going to solve an equation here. You're not going to add tangent or divide by cosine or anything like that. You can break down both sides at the same time, but you kind of have to do them individually a little bit. But I still think most of the time it's easier just to take the more complicated side and go from there. So for us, that's definitely going to be that left side. There's a lot more work we can do. It's also nice to think ahead and say, okay, I'm not done until I get to tangent. Remember, tangent is sine over cosine. So if you break this down, you get sine over cosine, you know officially that of course is tangent based upon our quotient identities. So what I'm going to do here is I'm going to just break down and do what we've done before. And the bread and butter, the one that we use quite a bit, is to break things down into sines and cosines. So tangent, we know simply that that's just sine over cosine. And then minus, I'm just going to rewrite that sine and cosine. And then that whole thing is being divided by sine squared. So that's about as far as I can go in terms of this. Now, one thing I noticed that I can write this as over 1. And I look, and I have, and we've talked about this for a long time, but one thing to kind of mention is you have to know the differences with this fractional stuff between if I divide or multiply like I've done, but if I add or subtract, you need a common denominator. I don't have a common denominator. This is a denominator of cosine. This is a denominator of 1, so I don't have that. But I know I can easily get that. I know that this is cosine, so I can multiply both top and bottom by the cosine of x. So that's what I'm going to do. So I can get that common denominator. And so down here, I'll have the sine of x over the cosine of x minus my denominator here. If I do 1 times cosine, that's of course just going to be cosine. And then on the top, you've got sine times cosine times cosine. Well, that sine's going to stay here, but cosine times cosine is going to be that cosine squared. And then that whole thing is being divided by sine squared. So there's a lot to kind of keep track of. Hopefully you have a little bit more room on your paper than I do. And sometimes, if we kind of just distinguish and say, hey, this is kind of a break here and this is kind of a break here, we can kind of see it a little bit better. Okay, so I've got that. I do have this now common denominator. So I've got that denominator of cosine. So I'm going to rewrite that once. My numerators, I'm going to subtract. So it's a sine minus sine times cosine. So I'm just going to write that out. Sine minus sine times cosine squared. So all I'm doing up here, I have that common denominator of cosine. I write that once. My numerator is sine minus this. So it's this numerator minus this numerator. That's where that one's coming from. And this still, again, this is still divided by that. Room here. So in this case, I still would be dividing by that sine squared. Okay, so now what do I do? Well, I could eventually do a keep it, change it, flip it thing, and I'm going to eventually do that because I have this fraction divided by this, and I can write that as over 1 if I want to. But one thing I noticed, if you look up here, looking up at this kind of, this way, if you look, you see up top, I have a sine minus a sine cosine. So we've talked about one of the strategies that you can use is the fact that if I have something that's in common, we talked about factoring it out. So both of these share that sign. So I can GCF that out. So that's something that you're able to do. So I'll kind of just get a little bit of room here. So if you factor out a GCF of sine, so if I factor out GCF of sine in this case, what I can do is, that's really dividing as we've been talking about. So if I take sine and divide it by sine, I'm left with 1 minus. If I take sine away from this, I'm just left with the cosine squared. So it looks like that. And again, you can double check that. Sine times 1 is sine. Sine times a negative cosine squared is that. So we've kind of had those conversations before. Then, if I simplify this further, this would still be divided by cosine. And then that whole thing is still being divided by sine squared. So I'm hoping there's something up here that you recognize, the fact that you can simplify. And that would be this. what does 1 minus cosine equal? Well, if you're looking at your identities, which I think is always a good idea, gotta make a little bit more room here. If you're looking at your identities, in this case, hopefully you recognize the fact that 1 minus cosine is really sine squared. So I would have sine, so up top, and we know that that's really sine squared, as we've talked about. That's one of those where we took the Pythagorean identity and solved a little bit. That's divided by cosine. And then that whole thing, so divided by thing, that whole thing is divided by sine squared. Now, I can multiply these guys together. So I'm getting really closer down. I know these tend to get decently long depending on the type of problem. Well, sine times sine squared, that's really like x times x squared, that's sine cubed. So I get sine cubed over cosine divided by sine squared. So now that I'm finally simplifying this a little bit more, one thing I can recognize is I can finally do this whole, hey, I've divided by a fraction, let's do that whole keep it, change it, flip it thing. So if I do that keep it, change it, flip it, I keep the top. So sine cubed over cosine, that stays the same. This division turns to multiplication, and then I flip this one. So this is really 1 over sine squared. And again, you can easily take these videos and watch them multiple times, and some of you would really benefit from doing it. You might not get it the first time, so definitely rewatch as many times as needed to fully understand it. Okay, so I've got a sine squared and a sine cubed. I can take a sine squared away from both. So if I have 2 sines and I take both of them away, it's gone. If I have 3 and I take 2 away, then I'm left with 1. And so then that would leave you with a sine on top and then a cosine on bottom, which of course is tangent. So that checks out. So I did eventually get there. Not much room to spare here. So again, I highly suggest you rewatch those examples a couple of times just to help you out. All right, another one. Again, pause it, write it down. Notice that this, if I look at this one, which side's more complicated? I think we can agree this side. So I get this, and now if you look, everything's in terms of sines and cosines. So one thing I need to do is, if there's nothing I can do that I can see, I do have 2 fractions. Well, I know that I could probably just get a common denominator. These are 2 completely different ones. So this denominator is cosine, this denominator is 1 minus sine. Well, if this is cosine, I can multiply top and bottom by this one. So over here, I'm going to multiply the top and bottom by cosine of b. And then over here, this is 1 minus sine. Now, what I want to do is, if it's a binomial, it's a whole binomial. So over here, I'm going to multiply by 1 minus sine. And this example is very similar to one that you did last week on one of the ed puzzles. Not the exact same, but very similar. So when I simplify this, now this is a binomial times a binomial. So that's the whole distributive property twice. So I need to say, okay, I need to do 1 times 1, so that's 1. And then I need to do 1 times negative sine, that's negative sine of b. Then I need to do negative sine times 1, so that's negative sine of b. And then I need to do negative times a negative, which is a plus, and then sine times sine, which is sine squared. On the bottom, I'm going to leave it alone. I'm going to leave this as the parentheses 1 minus the sine of b times cosine. So with the numerators, you always want to multiply. On the denominator, leave it in fractional form because you're hoping something cancels. Now, if nothing cancels and you have nothing else to do and you don't know where to go, then start worrying about this. But one of the key things with this is don't mess with the denominator right now. Do not distribute it unless there's nothing else to do. So this one, cosine times cosine, that's cosine squared. And then like I just said on the bottom, I'm going to leave it as 1 minus sine and then times cosine. So I'm going to leave that alone for right now. So leave that alone for right now. Now, notice that I do have a common denominator. So when I have this common denominator, I'm only going to write it once. So it's just going to be 1 minus sine of b that binomial times cosine. So again, leave that one alone for the time being. Then a couple things. I'm going to add up all these things at once, but I do have a couple. In this case, I've got some like terms here. This is a -1 sine b and another -1 sine b. So a negative, so first off, I've got this one. This is going to be 1, and then that'll give me a negative. Go back to my marker here. So in this case, that 1's going to drop down. Remember that this is really a -1 minus 1. That's -2 sine b. Then I have plus sine squared. And then over here, I've got plus cosine squared. So now I'm just adding. I added up all this numerator plus this numerator, and I also combined some like terms at the time too. Now, I'm hoping that if you look up there right now, hopefully something up at the top may jump out at you a little bit. So look at that top, see if anything's jumping out at you. What I'm hoping that you recognized was the fact that I have this. What does sine squared plus cosine squared equal? Well, that equals 1. So I'm going to rewrite the top, and then that turns to 1. And so what happens is I can continue to kind of do this problem, of course. But what that helps me do is I can combine this. This is 1 plus 1, which is 2. So I get 2 minus 2 sine b. And then I've got 1 minus the sine of b times the cosine of b. Okay, what can I do now? Well, there's nothing, doesn't seem like there's much, but what do these both have in common? We did the similar type of thing in the last example. They both share a 2, so I can GCF out a 2. So if I take away a 2, 2 divided by 2 is 1. If I take this 2 and divide it by 2, it's going to cancel the 2's out and leave me a sine b. Again, if you're not sure if you factor correctly, distribute it. 2 times 1 is 2. 2 times a negative sign is that. And then this whole thing is divided by, move that way real quick. This whole thing is going to be divided by this 1 minus sine of b times cosine of b. So I factor that. Now why? Well, when you factor it, since this wasn't factored up here, you can't cancel anything out. Now I can. What can I cancel out? What do I have exactly on the top and bottom? Well, I've got this whole binomial. With binomials, it's all or nothing. Either it cancels out or it doesn't. So it's either the entire binomial 1 minus sine b, or you cannot cancel it. You cannot cancel part of it. So this cancels out with that completely. And so what that does is that leaves me with, get some room here. That leaves me with a 2 over cosine. Now, real quick, I just want to rewrite this. That's really 2 times 1 over cosine of b. And I say that because we know that cosine of b is 1 over that is really secant. That's a reciprocal identity. If I go up to the very top, I'm not done until I got 2 secant, and there it is. There's 2 secant. So I encourage you to rewatch this as many times as you need to, because they're not easy. Some people want to cancel out stuff when they can't cancel out stuff. I see that quite a bit. So just kind of be careful with this. Ask questions, reach out, and do your best.